Hey guys, welcome to my SMTP video.
So, in this video presentation, we'll be going over what SMTP actually is, what uses it. I'll give a quick Python implementation demonstration. I'll then explain this Python code. I'll provide a wireshark analysis of the SMTP traffic we captured or did not capture. I'll then go over some security concerns, and then I'll say goodbye.
So what is SMTP? Well, SMTP, it stands for Simple Mail Transfer Protocol. It is a protocol that is used to send more than it is to receive, or only to send. So we call it a push protocol. It is used to push out messages between mail servers, and it is used to send emails from network to network. That's just a higher level look at it. There are a lot more details about SMTP, but I feel like they're a bit out of scope. Well, what actually uses SMTP? Well, pretty much everything. Email clients like Gmail, Hotmail, Yahoo, they all use SMTP. You've used SMTP. If you have a Deacon account and you have a Deacon email address, you have used SMTP. Uh, it's pretty common. I'm pretty sure you won't meet someone who hasn't encountered it. We all use it. So I think it's pretty interesting to see how it works. I'll give you a bit of a Python demonstration. Before I start my demonstration, I created a dummy Gmail account and I just wanted to show you it has nothing in its inbox. This stuff will be covered in the prerequisite knowledge that will be in the description of this video. For the code to work, you will have to follow the instructions set out. Google put some more security measures in place, which makes it harder for us to send emails through an unsecure or less sophisticated platform like our basic little Python program that I will show you shortly, but there is nothing in the sent inbox either. I just want to show you this before we get into it. But yeah, so here's the Python program, the SMTP client. I'm just going to run it for you first, so you can see the result. And once I've hooked you and you're all interested, I'll go through the code line by line and explain what it does. So I'll just run it for you. There we go, process finished with exit. So just opening Chrome, you can see that I have an email in my inbox and it was sent to me using Gmail. It was sent from 1.3 HD SIT202, which is me. And if I go into my sent, you can see that I have sent something as well. Now you're all interested, let's go back to the code. So to start, you have to import the SMTP library. You can do this with import SMTP lib. Just stands for, Simple Mail Transfer Protocol, lib for library, makes sense. Up next, we've got my email variable. It is the email address that we used and we set up the two-factor authentication on as outlined in the prerequisite document that is in the description and attached. The destination email is the email you want to send it to. For our demonstration, I used the email that was the one we used in the two-factor authentication as well, so I sent it to myself. The password is the Google-generated app password. It is the password that we got from the app passwords, and it's blurred out on your screen, because it is the actual password, and I'm a cybersecurity student. And the SMTP server variable, as the name suggests, is what we initialize the SMTP server. We use SSL with SMTP underscore SSL. The host is the smtp.gmail.com. That is Gmail's SMTP server, and we're using port 465. I'll talk more about this in the next section, but just for a brief overview, we'll skip past it. Going to the next line, SMTP server eHello. That's just to identify ourselves to the enhanced simple mail transfer protocol. More on this in the next section. The SMTP server login, just with the email and password provided earlier. Going into our email example, we are sending it from our source email, which was the source email we set up the TF2FA on. We are sending it to our destination email, which in my case was myself. The email text just has the body of the email, and the server.sendMail just sends the mail. It sends from the send from variable to the send to variable and has the body specified in email text. We then use SMTP server dot quit. Dot quit, it's just a more polite way to close, so to speak, rather than using dot close. It basically gives the server and yourself a chance to say your final goodbyes and wave at each other, rather than just walking off unannounced and everything ending. So going to our slides, now we're at the further code explanation. So what is eHello? So rather than using just a normal hello, we are using eHello. It is just a way that we identify ourselves, as I said, to the enhanced mail, simple mail transfer protocol. Which is what we're actually communicating with on the Gmail SMTP server. So that's why we're required to use eHello. And we used port number 465, which is the now depreciated, actually, SSL encrypted socket for SMTP. I believe 587 is the more modern port number to use for current applications. And that is because it's encrypted with TLS, not SSL. However, we're working with when working with legacy technology, you'll typically encounter 465 port numbers, and because SMTP lib uses SMTP SSL, it just works really well.
So I'll now provide a wireshark analysis and go over the captured transmissions from our previous program. Hello, welcome to the wireshark portion of this video. I'm going to show you how we can inspect our own SMTP traffic that we generated through our own SMTP client application that we created. Something interesting to note is what happens when you search for the SMTP protocol. Nothing comes up. Now this is because it is searching through protocols, but the way we made it, it doesn't appear under the SMTP protocol banner explicitly. To view our traffic, we have to go edit, find packet. This will be defaulting to display filter, but if you switch that to string and then search for SMTP, you can find our initial DNS query. This DNS query has A and then quadruple A. The singular A is a DNS query to find the IPv4 address of the server, and the quadruple A is to find the IPv6 address of the server. As you can see in the DNS responses, we have the IP address of the server and the IPv6 address of the server. After the initial hello sent by the TLS server, you can see a bit of a three-way handshake going on here. Application data is then transferred from the client to the SMTP server. Clicking on the TLS section, you can see that the application data protocol has transferred some simple mail transfer protocol data, which is what we want, SMTP, that's what we're dealing with. This is the application data. As you can see, it's exactly what I wrote. No, it's been encrypted using TLS version 1.3, but interesting that we can inspect something that we sent from our own program to ourselves. It's pretty cool just to step back and take a look at this. This is all us. We've done good. Good job, guys. But yeah, you can see that the application protocol is SMTP. That concludes the wireshark analysis portion. Now back to the rest. So now we've finished our wireshark analysis, let's go over some security concerns. Some security threats and concerns with SMTP. Obviously spam and phishing. This can be normal phishing and spear phishing, with the difference being spear phishing is more personalized and targeted. This is actually becoming increasingly popular and is something people really do need to be aware about. Spam, obviously, if fraudulent actors are able to access your server, your SMTP server, they are likely to use it to send spam emails to your contacts and your associated accounts. This ties into the unauthorized access portion. If a cybercriminal did gain unauthorized access to your SMTP server, they can capture all outgoing mail. This could contain things very valuable, such as images of passports or IDs or other personal and private information. This can be used for, say, impersonation reasons, or it could be used for blackmail, so on and so forth. Obviously, malware. If someone attached a payload to an email or an attachment and you were to open said email or attachment, you could have malware injected into your device, network, etc., which obviously is not optimal.
Thank you so much for taking time out of your day to listen to this, and I wish you all the best. Thank you.